Alright, today we're going to take a look at day number 10 notes on chapter 7. So we're today going to discuss special types of linear systems. Well, we're going to look at this both as a system itself. So we're going to give you a system. We're going to do it algebraically and solve it algebraically, see what that solution looks like. We're going to also graph it and see what that system looks like graphed. We're going to also look at these other two situations. One is what happens when there's no solution. And the last one over there is what happens if there are infinitely many solutions. So let's start here with the first one. I'm going to solve this system here. Let's go algebraically by, let's say, I'm going to go with linear combination. And what I'm going to do is I'm going to eliminate my y's. So I'm going to multiply the bottom equation by -3. And when I do that, the top equation is 2x minus 3y equals 15. The bottom equation becomes negative 9x plus 3y equals positive 6. Add going down, we're going to get negative 7x. The y is canceled out, equals 21. Divide by negative 7. X is equal to negative 3. When I plug this back in, I'm going to plug into the top. And when I plug back into the top equation, I get 2 times negative 3 minus 3y equals 15. Negative 6 minus 3y equals 15. Add 6. Negative 3y equals 21. Divide by negative 3. And y is going to be equal to negative 7. That tells me that my solution is negative 3 comma negative 7. Alright, let's take a look and see what happens when we graph this. I'm going to graph the top line in blue. If I want to graph that top line, I know that I can find my intercepts. My x-intercept, I'm going to do this over here on the side, is going to be 7.5, comma 0. And my y-intercept is 0, negative 5. Again, I can find each of those by letting the x or the y coordinate equal 0. And if I'm finding an x-intercept, I want to find the x value. If I plot that, 7.5 is right there. And 0, negative 5 is down there. Draw my line in. I'm going to graph the other line here in red if I want to find the x and y intercepts. Again, I like the fact it's in standard form. I think those are quick and easy ordered pairs to find. But if I plug 0 in for y, divide by 3, and I'm going to get negative 2/3. And if I plug 0 in for x, y will be positive 2. Where is negative 2/3 comma 0 might be the question as we look at this ordered pair right here. Well, remember negative 2/3 is going to be a value that's between 0 and negative 1, closer to negative 1. So I'm going to approximate that and just say it's right about there. When I draw my line in, draw my line in as best I can. And as I take a look at this, where is my solution? Well, my solution is this point right here where the two lines cross. And if I look at that, that is the point of intersection. Which above we stated as negative 3 comma negative 7. Voila. All right, let's take a look at problem number 2. And problem number 2, I'm going to use substitution. I'm going to take this 3x plus 2, plug it in there for x. I'm going to get 12 times 3x plus 2 minus 4y equals 8. Let me back that up real fast. Where am I plugging? Testing you guys to make sure you're paying attention. we are still sticking with substitution, but I'm going to take 3x plus 2, and I'm going to plug that in for, sorry, that was plugging it in for y. I miswrote that before, and that's why I had to erase and start again. So I'm going to get 12x minus 4 times, here is where we're plugging in 3x plus 2. And that's going to be equal to 8. Remember here that we are going to make sure that we distribute a negative 4 when we use that distribute property. So that's going to be plus negative 12x plus negative 8 equals 8. If I add like terms on the left side, the x's cancel out, and I get is negative 8 equal to positive 8. And you say, is negative 8 equal to positive 8? And we say, no way. So that is why this is a false statement. And when we have a false statement, we end up with no solution. What that means is that there is no number or no ordered pair that you could plug in and make that statement true. Well, let's see what this looks like if we were to graph it. I'm going to graph the first line using slope-intercept form. I'm going to use a y-intercept of 2 and go up 3 and write 1. Enjoy the ability to draw a very straight line here and draw it in. When I take a look at the second line, well, the second line is going to be in standard form. It's often easier to find our intercepts here. If I were to find my intercept and I plug in 0 for y, I'm going to get 12 times what number is equal to 8. Well, if you're trying to find that, you're going to divide by 12 on both sides, and we're going to get 8 12s, which is also equivalent to 2/3. If I want to find the y-intercept, I'm going to let x be 0. Oops, sorry. I'm going to let x be 0, and we know negative 4 times negative 2 will be 0, negative 2 is that ordered pair. There is 0, negative 2. 2/3 common 0, like we talked about in the previous problem, is an ordered pair that's between 0 and 1, closer to a 1. And when I draw my line in here, I'm going to draw my line going through those ordered pairs. What we end up getting here is a situation where we have what are discussed as parallel lines. And we know that parallel lines do not intersect, that is why there's no solution, because we can't find an ordered pair or a point of intersection because they don't intersect anywhere. Let's look at the third example here. The third example here, again, I'm going to use substitution. I'm going to take what y is equal to. I plug it into the top equation for y. I'm going to put a note here on the side that reminds us we are doing substitution. I will make sure that I substitute in for y this time. And we get 8 times, I'll do that in a different color just to make it more visually appealing. And that equals 24. I'm going to use the distributive property. I'm going to get 8 times negative 3/4 is negative 6x. 8 times 3 is in fact 24. And that equals 24. If I add up like terms, those x's cancel out, and I get, does 24 equal 24? Well, this is a true statement. What does a true statement means? It means that any ordered pair I plug in would be a solution. So we can call this infinite number of solutions. Well, why is there an infinite number of solutions? Well, we're about ready to see that there's going to be a lot of points that are going to satisfy being a solution here, and we'll see what that looks like in our graph. When I get ready to graph it, I am going to graph them in 2 different colors. The top line I'm going to graph using my intercepts. So 6 times what number is 24? That is 4. If I plug 0 in for x, 8 times what number is 24? That will be 3. So I can graph 0, 3. And 4, 0. I'm going to draw my line in. Ooh, let's see if I can get this one better. I can't always cut, and I can twist and move it all around. But there is our first line. If I want to graph the second line is in y equals mx plus b, so I'm going to graph 3 as my y-intercept, and I'm going to go down 3 and right 4. 1, 2, 3, 1, 2, 3, 4. What we're noticing here is that these points I'm getting, down 1, 2, 3, over 1, 2, 3, 4, are the same points we just graphed before, and they are all the points on the line. So the question is, where does the red line intersect the blue line? The red line is going to intersect the blue line everywhere on that line. And what we get here is a situation where we are looking at the same line. All right, same, a little bit neater. But we get the same line. And what that means is that any point that is on that line would be a solution, which is why there are so many solutions. So it's not just 0, -3, and it's not 4, 0, or that's 8, -3. Any point that is on that line would satisfy being a solution. And that there is a wrap on special type of linear systems. Your next up is to work on day number 10 homework.